Hi, I'm Andy, and welcome to my walkthrough of the 2020 Sans Holiday hack. In the previous video, we discovered that the secret room in the workshop led us through the painting of Santa in order to take on his appearance. This is what Jack Frost must have done to then be able to sabotage operations at the North Pole. Our next objective is to uncover the name of the adversary group that was expected to attack KringleCon. But we'll first stop off en route to help Minty with the Sort-o-Matic, as they'll give us some hints for the main objective in return. We'll go back through the painting to return to our normal form, as I'm sure pretending to be Santa without a very good reason would land me on the naughty list. We're told that the Sort-o-Matic is responsible for sifting out broken toys, but it's not working properly. To get it working again, we must provide the correct regular expressions. First, we must match any digit. This is fairly simple. We just need to specify the range of 0 to 9 within square brackets. This is known as a set. Next up, matching any 3 letters regardless of case. We can use a set again of A to Z, but we need to specify lower as well as uppercase. Currently, this matches just a single occurrence of a letter, but we're tasked with matching 3. This can be achieved by adding the number 3 in curly braces immediately after the set. The third question wants a regex for any 2 lowercase letters or digits. This is similar to before, but now the set matches A to Z and 0 to 9, and the quantifier in the curly braces is 2. For the fourth, we must match any 2 characters which are not uppercase A through L or 1 through 5. We can start by doing the exact opposite, matching A to L or 1 to 5, and then adding a caret symbol at the start of the set to negate it. And we'll need a quantifier of 2 to finish off. Next, we'll need to match 3 or more digits. We'll start with a repeat of the set from question 1. To match 3 digits, we'd set a quantifier of just 3, but we're asked for 3 or more, so we need a comma to specify a range. We could specify an upper bound after the comma, but the question doesn't require it here. And finally, this currently matches items which contain 3 or more digits anywhere, but the question asks for only 3 or more digits. So we need to specify the start of line with a caret symbol, and the end of line with a dollar symbol. And yes, that is the same caret as we used for negating a set, but note that this time it appears outside the set definition, not within it. Now things are getting trickier, and thankfully we have some examples to help clarify exactly what should be matched. We need to match one of several different time formats only. Let's start with hours. The first digit of an hour is either a 0, a 1 or a 2, but it is sometimes omitted altogether in the case of single-digit hours. We can use a question mark to optionally match. The second digit is a simple set of digits 0 to 9. This does admittedly mean we'll also match some invalid hours, such as 24 through 29, but hopefully this is acceptable. The minutes and seconds are simpler, with their first digits being 0 to 5 and second digit 0 to 9, both of which should always be present. Each of these 3 are then joined by a colon character, and we must also add the start of line caret and end of line dollar to only match times and nothing else. Question 7 wants to match MAC addresses regardless of case. A single hexadecimal digit can be matched with a set of letters A to F in both cases and digits 0 to 9. Then add a quantifier of 2 to match a pair of hex digits. A MAC is 6 of these hex pairs, separated by a colon, so we can just copy and paste a few times. And finally, add the start of line caret and end of line dollar. The last question wants to match one of several date formats. The day is 2 numerical digits, although the first must be within 0 to 3, whereas the second can be any digit. Again, this could match some invalid dates, like the 37th day of a month, but hopefully the question doesn't want us to be that specific. The month is also a 2-digit number, but this time the first digit can only be a 0 or a 1. The year can be any 4 digits. Each of these components can be separated with either a forward slash, a dot, or a dash. These are all special characters in the eyes of regular expressions. We've seen the dash used to specify a range of values, and the dot acts as a wildcard matching any single character. So these characters must be escaped with a backslash in order to match the literal character. Combining these components together, along with the caret and dollar to define the start and end boundary, produces this final regex. It is accepted, and with the Sort-o-Matic working correctly, Minty provides a few hints. Back to the main objective. We must access the Splunk terminal, but we're initially denied access. Only a small number of elves and Santa himself are allowed. Luckily for us, we have a way to make it look like we're Santa, so after a quick hop back through the workshop and through the painting, we are given access. There's a series of questions to answer, guided by a simulated conversation with Alice. Alice has simulated a number of attacks using the Atomic Red Team suite, and has arranged the events associated with each in its own Splunk index. The attacks launched by Atomic Red Team are aligned to the MITRE attack framework, which is also the same framework that I use in my YouTube series Attack Detect Defend. Go check it out sometime. The first question is to identify how many attack techniques Alice emulated. She provides a query to get us started. This lists out each of the indexes and how many events are recorded in each. Many tactics have a -main and a -win index. The latter contains events from the targeted host, and the former from the other monitoring systems such as Zeek. They both relate to the same attack, so shouldn't be double counted. So there's a total of 13 unique attack techniques here. The next question asks for the index names associated with the simulated attack using technique T1059.003. As mentioned earlier, this is the -main and -win indexes. Question 3 asks for the registry key that's queried to determine the machine GUID as part of the System Information Discovery technique. A search over on the MITRE attack website indicates the ID of this technique is T1082. Then, over on the Atomic Red Team GitHub page, a search for this ID number brings back a few results, including the YAML file which defines the commands that are executed. The GUID discovery test is at the end of the file, and it's clear to see the specific registry key which is being queried. The next question asks for the timestamp of when the first OS/TAP related attack was performed. The conversation with Alice provides a reminder that an event is created in the attack index when each attack is launched. Searching this index for OS/TAP produces just 5 results. These are sorted in time descending order, so the timestamp we need is the last one. Question 5 asks about the process ID associated with an attack which makes use of a package authored by GitHub user frgnca. This is a bit of a cryptic question, but we can start by heading over to the Atomic Red Team GitHub page and searching for this user. There's no results, so let's try flipping this problem around and seeing what packages frgnca has developed. There's a few different repositories here, but it's clear from previous tests that the target is a Windows machine, and only one repo seems to be specifically related to Windows. It seems to be a set of PowerShell-based audio tools, which is a bit odd as very few attack techniques involve audio, but let's pivot off this anyway and search the Atomic Red Team repo for anything audio related. The first couple of results are T1132, which involve recording audio to gather sensitive information. The second of these also has the same name of those PowerShell-based audio tools. So we can pivot off the technique ID to search only that index. Further filters can be added to narrow in on sys1 events only, and only event ID number 1, process creation events. There's still over 200 events to sift through here, so let's narrow down a bit further by only including items where the word audio is present in the command line, After all, this is included in the name of the PowerShell tools. 2 events are returned, again with the earliest event being the one at the bottom. The process ID associated with this is 3648. Question 6 asks for the last line of the batch file which simulated the abuse of Windows registry run keys. A browse of the attack matrix indicates that this technique is ID number T1547.001, so we can search just this index. The search can be narrowed down to only those events where the command line field contains .bat. There's a few results to investigate here, although the final item appears the most promising, as it's a batch file directly linked from the Atomic Red Team repo. Navigating to that location displays the script, where the final command is queuser, and this is indeed the correct answer. The final training question is to identify the serial number of the TLS certificate assigned to the Windows domain controller as captured by Zeek. Alice advises that these events have a source type of bro, the old name for Zeek. Digging deeper into the source type reveals events specific to X509, so we can narrow our search by clicking on that to add it to the filter. There's still over 2,000 events to sift through, but the field summaries indicate that there's only 12 distinct values for the certificate subject. Taking a closer look, the most frequent include WinDC in the name, so this is almost certainly a domain controller. Another click drills down to just events with this subject name. And there's only a single certificate serial number amongst the remaining 1,000 plus events. This completes the final training question, upon which Alice shares the overall goal of this objective, the name of the adversary group which Santa feared would attack KringleCon this year. But she provides it as a base 64 encoded ciphertext, encrypted with a key that's disclosed in the KringleCon talk given by Dave Herald. That passphrase is "Stay Frosty," but we'll also need to know the crypto algorithm to complete the decryption. Alice suggests that she cares not for RFC 7465, which is explicitly concerned with the depreciation of the RC4 stream cipher. We can cook up a recipe in CyberChef to decode from base 64, and then perform an RC4 decryption using the Stay Frosty key. The end result, the adversary group, is the Lollipop Guild. All that's left is to plug this into our badge to collect the completion achievement. That's all for this video, but leave a comment if you have any questions or if you used a different method for solving any of these puzzles. We'll pick up the story in part 7, where we'll be exploring how electronic systems in cars communicate with each other. Feel free to take a slight detour on your way and check out some of my other cybersecurity videos, otherwise I'll see you there.